All right, welcome to the next section of Chapter 6, where we're going to talk about a midsegment in a triangle, and then a couple of different types of inequalities that occur within triangles, so how angles and sides measure up to one another. So the first thing we're going to discuss is what we call the midsegment, so we're going to define that. And basically the midsegment of a triangle is a segment that connects the midpoints of the two sides of a triangle. So the big thing here is that it's the midpoints of the two sides. So in the picture below here, for instance, line MP, when I draw in line MP, so I highlight it there, we notice that it cuts this side of the big triangle in half, and it cuts the other side in half as well. So I'm hitting point M as a midpoint, point P as a midpoint. That's what we mean when we're talking about a mid-segment. So it cuts the two sides in half on either side. Now, within each triangle, we could technically create 3 mid-segments. So I can also see then that P to N. Well, P we already said was a midpoint because it cuts BC in half. And now P to N, I notice that it cuts side AN and NC in half. And then we also have a third one if we highlight from M to N. So I've got 3 different mid-segments. Basically, if I go around the outside of my triangle and I draw 3 midpoints, so point M, point P, and point N are all midpoints. When I connect them, I create what's known as the mid-segment triangle. And so inside there we have that mid-segment triangle, which is going to be half the size of the original. Okay? Now, as far as the mid-segment goes, besides being able to identify it, there's a couple things we need to know about it. So when we draw a mid-segment into a triangle, so here we have DE being drawn into my triangle here. So we connected the midpoints. We see that we cut this side in half, and we see that we cut this side in half. There's 2 things about this mid-segment that are important. First, that mid-segment is going to be parallel. That's what these little arrows mean. So it's going to be parallel to that third side. So it's parallel to side AC. Now, how does that help us? Well, it tells us things like angle BED right here that I've highlighted is exactly the same as angle C down here. Or that angle BDE over here on the left is the same as angle A down here. So parallel lines give us things like those corresponding and alternate interior angles. And so that's one of the things that we need to make sure we know. Now the other thing is that when I look at this picture, so line DE was my mid-segment. The other thing that's important here is that that mid-segment is half the size of that third side. Meaning, if I told you that AC had a total length of 20, DE would be half of that length, and that would be 10. Or, and some of the problems that you might come across here, you have, the other thing you might get is something like DE is X plus 2, and AC is, let's say 30. Okay, so basically what has to happen here is I need to take 2 of these mid-segments to equal 1 of the outside. So I can take 2 times my mid-segment is equal to 1 of the outsides. And then I can distribute the 2 and solve for X that way. So if you get expressions with X, the big thing to remember is I have to take 2 of the middles to equal 1 of the outside. And that's going to be a kind of important concept there. So if it's just the numbers, it's just a matter of matching them up. So DE has a length of 24. The outside has to be twice as big, so 48. So that's the key thing there. So if we look at a quick example here, okay, so it says triangles are used for the strength in roof trusses. In the diagram, UV and VW are mid-segments of triangle RST. So the first thing, we're focusing on this big triangle RST. So that's kind of where we're starting here. And then what they're telling us is that in this picture, UV is a mid-segment and VW is a mid-segment. Now what that tells us is that for UV, U is the midpoint of this side, V is the midpoint of this side. The fact that they said VW is also a mid-segment means that W is the midpoint of this side. So basically we're cutting that entire triangle in half all the way around. So SR gets cut in half, ST and RT. Now if we look at the picture here, it says find the length of UV and find the length of RS. So I want to know how big UV is, and I want to know how big RS is. So UV is the mid-segment. Now if I notice, then I go across to the opposite side here, that side is 90 inches long. So UV should be half as big as the 90, which means it's going to be 45 inches. When I go to find the length of RS, so RS is over here, I look at this mid-segment that goes with it, so the mid-segment VW. Now the mid-segment is 57, so when I want to go all the way out to RS, the outside would be twice as big as the mid-segment, and so I get a total length of 114 inches. So when you're working with the mid-segment, the inside is always half as big as the outside, and that's going to be the key thing that we need to remember here. So it's multiply or divide by 2 to get the missing measures. Now, within triangles, we're going to talk about some inequalities, some relationships between angles and sides. The first thing is fairly intuitive. It's fairly straightforward. Basically, we're saying that the longest side of the triangle has to be across from the largest angle. So longest side in the triangle across from the largest angle. So I'm looking at those opposite pieces here. On the flip side of that, the shortest side of the triangle will always be across from the smallest angle. So again, if I look at these opposite pieces, the smallest angle always has to be across from the smallest side. The longest angle or largest angle always has to be across from the longest side. And so that's kind of a pretty straightforward idea. Now what that means then is when we look at a picture like we see here, triangle ABC. So in triangle ABC, we have two side lengths. We have AB is 8 and BC is 5. Now what they want to know is, given this triangle, based on those two side lengths, which angle is bigger, angle A or angle C? And so we have to use the idea that the bigger the angle, the bigger the side, and vice versa. So angle or side AB is 8 units long, which is bigger than side 5. So the angle across C, so angle C, is bigger than what's across from 5, which is A. So we say the measure of angle C is greater than the measure of angle A. And this is the thing where we have to make sure we know our signs, greater than, less than. So when the arrow points to the right, we have a greater than symbol. The left number is bigger than the right. Less than, so if I wanted to flip this statement around, we could say measure of angle A is less than the measure of angle C. And so the less than symbol points to the left. So be really careful when you're answering these types of questions that you get the greater than or less than symbol put in correctly. So if I have bigger side, means bigger angle across from it. Okay. It also works the other way. If we start with angles, we can determine which side is longer based on how big the angles are. So right now I have these two angles given to me. My bigger angle is 50, so if I follow it across to the opposite side, we get BC. And if we follow the 30 across to the opposite side, we get AB. And so what this statement is saying is that line BC has to be bigger than line AB. And again, that's that greater than symbol that we have to be careful with. Or we could say AB is less than BC because it was smaller. Okay. Now one quick note here. If in this problem, and this also applies to the previous problem, if they had instead told us that both of these angles are 50. So if we ever get a situation where both angles are exactly the same, remember that means that the sides opposite those will also be the same. So AB and BC would be identical. So that's another scenario you might want to just kind of keep an eye on. If they're different lengths or different sizes, then the sides or angles will be different sizes. But if they're ever identical, if they ever have the exact same angle measure or exact same side length, then the others are going to be the exact same as well. So if we kind of put all this together, looking at the picture here, it says you're constructing a stage prop, shows a large triangular mountain. So we're looking at this triangle right here. Okay. The bottom edge of the mountain is 32 feet long. So let's do the bottom here. Let's label that 32 feet. The left slope is 24. So if we go to the left side here, we got 24 feet. And the right slope is about 26. So we're going to put 26 over here on the right. It says list the angles of triangle JKL in order from smallest to largest. Now here's where we got to pay really close attention. We want the smallest angle first, the largest angle last. So if I take a look at this picture down here, I want to start with the smallest. Well, so in order to get that, I need the smallest side. So here's my smallest side over here, 24 feet. When I go across my triangle, that means my first angle would be angle L. So angle L would be my smallest angle. Then if I start working my way up the triangle, 26 feet would be my next biggest side. So I'm going to go across and we find angle J. And then our last side, our largest side, would be 32 feet. I follow it across and I find that we get angle K. So L smallest, J middle, K biggest. And don't forget your angle symbols when you're naming angles. So that's kind of how we're using those theorems, is just to kind of think biggest side, biggest angle, smallest side, smallest angle. Again, we can do this with our angles first. So in this case, they want us to say the sides in order from shortest to longest. We're going to start with the smallest again. Now, if I'm looking at this picture, I know 2 of the 3 angles. I need to find that third angle before I can start putting things in order. So this is where we talk about using that 180. All 3 angles have to add up to 180. So if I take 180 minus 51 minus 47, I get my final angle in the picture, which in this case would be 82. So now if I'm looking at all 3 angles here, I want the shortest side first. So that means I need to find the smallest angle, which is 47. When I follow it across the triangle, we get side DF. So side DF would be my shortest side. My next smallest angle would be 51, so I go across there, and that means my next smallest side would be EF. And then my last side is across from my biggest angle, 82, and that would be side DE. And then again, as you're listing these sides, make sure you put the line segment symbol. So line segment DF, line segment EF, line segment DE, and that's our order from shortest to longest. Kind of the last main idea here, the triangle inequality theorem. This is going to be a really big one. We're going to spend some time tomorrow working with this as well. What I want you to know with this triangle inequality theorem, forget all of these statements right here. They have you check 3 different scenarios to make sure that a triangle exists. What we really need to make sure of, or what we really need to figure out, is for this, the 2 smallest sides. So 2 smallest sides must always add to more than the biggest side. So what I want you to understand here is I'm going to find my 2 smallest sides, and they have to add up to more than the biggest side. So if we're looking at the picture that we have there, and I'm going to erase some of this statement so we can kind of get a feel for what we're looking at here, just by going off of looks, we know that, or just kind of what we see here, this is going to be my smallest side. This would be another small side, and this is going to be my big side. Okay, so basically what I have to identify is which of the 3 sides is the longest. That's my big side. Both of the others are going to be small. And so what we're saying here is the small side plus the other small side has to be greater than the big side. So every time when we start looking through a triangle and they're trying to figure out, okay, can we make a triangle from these measurements? The small plus small has to be larger than the big. And so if we look at some examples here, it says determine whether it's possible to construct a triangle with a given side length. So the first thing we're going to do is we're going to look at this. We have these 3 side lengths. Can we make a triangle out of it? And so what we have to do is we have to figure out, okay, well, here's my biggest side, 10. So I need to take the 2 smallest sides, 4 plus 9, and add them together. So 4 plus 9 is 13. That is bigger than 10. And so we have to always compare what's the biggest side. So since 13 is bigger than 10, that means yes, we can create a triangle. When we look at the second example, so here we're looking at this one here in purple, the biggest side is 18, so we want to kind of keep that in mind. I'm going to take the 2 smallest sides, 8 plus 9, and when I add those together, I get 17. Now 17 is smaller than 18. And so those 2 sides, 8 and 9, can't come together and meet, which means there is not a triangle here. This is a no. Those 2 smalls have to add up to more than the big. And so if we look at the last example, so right here, again, we identify our largest side, which is 12. And if I add the two smaller, so 5 plus 7, I get 12. Now 12 is actually exactly the same as my largest side, 12. Again, when we do this, the two smallest sides have to be bigger. They can't be the same, they can't be less, they have to be strictly bigger than that third side. So in this case, even though we're close, we do not have a triangle. Now, one thing to note here, when you're working with something like this, as long as it's bigger in any capacity. So if I had 5.1, 7, and 12, if I was looking to see if those form a triangle, 12 is my biggest side. So 5.1 plus 7 would be 12.1. Now, even though 12.1 is barely bigger, it is bigger than 12, which means, yes, we could make a triangle out of that. So the two smallest, as long as they're bigger than the third, that's what we're looking for. So small plus small always has to equal or be larger than big. Last thing here, if we're given a triangle with two side lengths, so a triangle has a side length of 14 and another side of 9, what are the possible lengths of the third side? So in this kind of situation, what we have to consider is two possibilities. Either 14 and 9 are the two smallest, and so if the two smallest sides are 9 and 14, if I add those together, 9 plus 14 is equal to 23. Now what I know then is my third side, if those are my two smallest, my third side has to be smaller than 23. So regardless of what's happening here, I have to be less than 23. Now the other situation that could happen here is that 14 might actually be my biggest side. Well, so if I have my biggest side of 14, then I would want to take that big side minus the one side I already know, and that means my smallest side would have to be at least 5. So basically what we're doing here is we're calculating a range of values. Where does my third side have to fall? So it's got to be less than 23, it's got to be bigger than 5. So the way we write that is 5 is less than x is less than 23. We're just going to put x, our missing side, in between 5 and 23. Okay? And on these types of problems, what I'm really concerned with is, can you find the two cutoff points in the problem? So it's add the two sides together, because those might be the smallest. There's your upper bound. And then subtract the two sides. There's your lower bound. And then put them together into a statement that shows that x, or a third side, has to be somewhere in between. So with that, you should be able to work through the worksheet that you get in class or that you need to print off of Google Classroom. As you work, if you have questions, make sure you ask in class or email. Make sure you check the answer key when that comes or becomes available, and make sure you have that ready to go for when we collect that in class.